Welcome to Lesson 3 of Eureka Story of Ratios. So the first two lessons, we built this idea that a ratio is an ordered pair of numbers. And we wrote that ordered pair in the format A to B, with that word 2 in between. Or we wrote it A colon B. And remember, order matters in ratios. That's why it's an ordered pair of numbers. So knowing this, we created sentences to go along with some ratios. So now it's time to practice that again. I'll give you an example, but come up with your own. So my example for exercise 1, a one-sentence story problem, would be there are three monkeys for every 6 bananas. So go ahead and pause, try to think of a sentence, and then click play and continue on the video so we can work on creating the ratio from the sentence. So in here, in this sentence, I'm going to highlight what I notice. First, we have our A, 3 monkeys for every B, 6 bananas. We write it in the order we see it. So if I'm going to write that ratio, I see A to B. I'm going to write A, B, just to really hone that in. We see that there are 3 monkeys to every 6 bananas, or also written as 3 colon 6. Do the same thing with your ratio. Pause the video, and then we'll continue on to exercise 2. All right, now let's build on this knowledge. We're going to try to create some equivalent ratios, but first we're going to use what we know to create a ratio table. So I know I can read that Shani and Mel are using ribbons to decorate a project in their art class. The ratio of the length of Shani's ribbon to the length of Mel's ribbon is 7:3. Keeping that in mind, we're going to keep it in order. Shani is A, Mel is B, 7:3. All right. Let's use that information to first start out by creating a table so we have some numbers to work with. All right, S for Shani's ribbon length, M for Mel's ribbon length. I'm going to create a table here. All right, so I already know that for every 7 lengths that Shani has, Mel has 3. What happens if we double Shani's? So if we double it, we get 14. And we have to do the same thing for Mel's because the ratio has to stay the same. Double it, we get 6. What if we triple Shani's ribbon and we triple Mel's ribbon? We get 21 and 9. Now that we got some numbers, let's use what's called a tape diagram to show how this works. So I'm going to first highlight my first row just so you can keep track of where all these are coming from. I'm going to use orange. I'm even going to draw the tape diagrams in orange to make it easy. So when I draw a tape diagram, I've got to label it and stack it. So I'm going to write S for Shani, M for Mel, labeled and stacked. And I see my first number is 7. So I'm going to draw a nice long rectangle I could break into 7 pieces. Go 2, 3, 4, 5, 6, 7. And then I want to keep the boxes roughly the same for Mel because we're comparing these two numbers. All right, now that we have that, we know that the first one is only their length once. So I'm going to put a 1 in each of those boxes. So I've noticed that there's 7 boxes, and each box is 1 length long. That's going to give me my 7. Same with Mel, we've got 3 boxes, each 1 length long, gives me my 3. that is showing that our ratio is 7 to 3. Let's see how we could use this information to get this 14 to 6. So I see my 14 to 6. I'm thinking I could keep the boxes the same. So we have Shani, we have Mel. We're going to create that same diagram of 7. 2, 3, 4, 5, 6, 7. And then Mel's around the same length for 3. 1, 2, 3. But I'm going to notice that these were doubled. So each length should be twice that of the first ratio. I'm going to put a 2 in each box to show that it's twice the first ratio. 2, 2, 2, 2. Same idea. We have 7 boxes for Shani. Each box is worth 2. That gives us our 14. Same with Mel. We have 3 boxes by 2 in each box. Gives me my 6. So that shows that ratio of 14 to 6. Go ahead and try the last one on your own. Create that same tape diagram 7 and 3 and put 3 in each box because we tripled the length of both of them. And see if you can figure that ratio. And I'll do it at the same time and see if we get the same answer. I'm drawing my 7, 2, 3, 4, 5, 6, 7, 1, 2, 3, 1, 2, 3, 1, 2, 3. I'm going to put 3 in each box. 3, 3, 3, 3, 3, 3, 3, 3, 3. Alright, 7 times 3 equals 21. So 3 times 3 equals 6. Ooh, not 6. 9. 21 to 9. Alright, did you get 21 to 9? If not, you can rewind and see how I did it. Alright, let's try applying this to exercise 3. And we're just going to start with A. We'll get to B in a minute. We'll start with A. But I'm going to do the same idea of highlighting the important parts that I notice in the story problem. So let's read it. Mason and Lainey ran laps to the train for the long distance running team. The ratio of the number of laps, it said the ratio, so I'm going to highlight the number of laps Mason ran to the number of laps Lainey ran was, and I'm going to circle that ratio to as a reminder what the ratio is going to be. 2 to 3. So Mason is my A, Lainey is my B, and it's 2 to 3. So if Mason ran 4 miles, how far did Lainey run? Draw a tape diagram. So I'm going to first start out by drawing my tape diagram. My A is Mason, so I'm going to label that with an M. Give Mason 2 boxes for that ratio. I'm going to label L for Lainey. Give it 3 boxes. Divide that into 3 roughly even boxes. And we're given the information that Mason's total run was 4 miles. So now I need to think about how I can get 4 equally into these boxes because all the boxes are going to be the same amount. So I notice there's 2 boxes, so all I would have to do is 4 divided by 2 to get the amount. I get 2, so I'm going to put 2 in each box. Knowing that all the boxes are the same, I can put them in Lainey's. What we're looking for is this total here. So I notice that there are 3 boxes, 2 in each box, gives me my 6. So I'm going to write a full sentence to show that I know what's happening. So Lainey ran 6 miles. And that is demonstrated with the tape diagram, like we did in exercise 2. We're just doing the same thing in exercise 3. All right, let's scroll. So now, if Lainey ran 930 meters, how far did Mason run? So we're going to start with that same tape diagram. So I'm going to write M, L, draw my 2 boxes, because it's 2 to 3, right? Up here, 2 to 3. So we've got 2 boxes. Draw my 3 boxes. All right. So we are told that Lainey's total run this whole length is 930 meters. We're looking for how far did Mason run. Put that a big question mark. So we have to get 930 into 3 boxes. 1, 2, 3. So I'm just going to do 930 divided by 3. You can use long division if you need to, but I know that's 310. So in each box, I'm going to put 310, 310, 310, 310, 310. All right. Now that we know what each box is, we can use that information to figure out the total length that Mason ran. So I know that Mason ran 2 boxes long. Each box is 310 meters long. That gives us 620. Once again, I'm going to write that in our sentence format. So Mason ran 620. In our question it says meters, so I'm going to write M for meters to give all the information there. Nice work. Those tape diagrams really come in handy to notice what's happening. So like we noticed above in exercise 2, we had some equivalent ratios, 7 to 3, 14 to 6, 21 to 9. We can look at 2 to 3, like we just did in this problem, the same way. So I'm going to stack them. I'm going to write 2 to 3. We can look at part A and notice we have 4 to 6 for the bottom, 4 to 6. I'm going to write 4, 6. Same idea here. We had 620 to 930. 620 to 930, because we had Mason to Lainey. I just want you to see that this is multiplied by the same thing too. This is multiplied by the same thing, 310. 310 times 2 is 620. 310 times 3 is 930. Nice job. All right, try exercise 4 all on your own. I'm going to complete it now just so you can watch and see how it's done. But I want you to try this on your own, then come back and watch to see how I did it and match and see if it was the same. All right. First, I'm going to start out by highlighting the information they give me. Josie took a long multiple choice end of year vocabulary test. The ratio, okay, I'm going to notice my A's and my B's. The number of problems Josie got incorrect to the number of problems she got correct. Circle in that ratio. 2 to 9. Ooh, I would love to circle that in red instead, just to make it extra clear what the ratio is. 2 to 9. So if we look at A, it's asking if Josie missed 8 questions, how many did she get correct? Draw a tape diagram to demonstrate how we did this. So we're going to do the same idea as the first 2 exercises. So I see that we're looking at incorrect A to correct B. I'm going to write I for incorrect, C for correct. And we're just going to do 2, 2, 9. 2 to 9. And it takes a second to draw because there's so many parts. So we're given that she missed 8. She got 8 incorrect in total. She missed 8. So this whole thing is 8. I know 8 has to go into 2 boxes, so I'm going to go 8 divided by 2. That's going to give me my 4 in each box. So 4 questions in each box. 4, 4, 4, 4, 4, 4, 4, 4, 4. And then we're looking for this. How many questions did she get correct? And I noticed that there are 9 boxes, 4 questions in each box. 9 times 4 is 36. Add that sentence at the end there. Josie got 36 questions correct. All right, just like that, we use the tape diagram. Goes by super fast if you know where all the numbers go. It's going to take some practice, but we're going to keep on trying. So now, using that same 2 to 9, I'm going to write it over here so we don't forget. 2 to 9. We're going to look at if Josie missed 20 questions, how many did she get correct? So drawing that 2 to 9. Drawing that 2 to 9. I'm going to start by writing my I and my C to keep my stuff organized. 2, 4, 6, 8, 9. Kind of counted out so they were somewhat even. 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8, 9. 9, 2 to 9. Alright, and we're given that she missed 20 questions. She got incorrect. Missed 20 questions. 20 goes into 2 boxes evenly, and we can do that by 20 divided by the number of boxes 2. Gives us 10. I'm going to put 10 in each of my boxes. You don't have to put the 10 in, but while we're learning in the beginning, it might be smart to remind you that there's 10 in each box. What we are looking for here is how many did she get correct? This number here. So if there's 10 in each box and we have 9 boxes, 9 boxes by 10 in each box, 90 questions correct. And right in that sentence, really clear sentence of Josie got 90 questions correct. Nice work. I want you to complete exercise 4, if you haven't already, and figure out what ratios can we say are equivalent to 9, 2, and 9. Let me give you a hint. Our ratios we just created, and the first one was 8 to 36. This one was 20 to 90. That might or might not help you with our ratios. All right. In our lesson summary for today, we notice that 2 ratios, A and B, are equivalent if the ratios are non-zero. Keep that in mind, non-zero numbers. C, such as C equals CA, B equals CB. For example, 2 ratios are equivalent if they both have values that are equal. So this is just saying we multiplied A and B by the same thing to get our new ratio, C to D. We did A to B times that whole thing by this number C is going to give you C to D, the new ratio. But they are equivalent. Ratios are equivalent if there is a non-zero number that can be multiplied by both quantities both quantities in one ratio to equal to the corresponding quantities. All right. To finish off the lesson, I'd love if you could do exit ticket. 3. Problem set 3. You can either turn these in online or paper copy is both acceptable. I just want to see you're learning how you're developing. Awesome job. Great lesson today.